Law of CoSines. So, the way that Law of CoSines is set up is that you have, it should be c squared is equal to a squared plus b squared minus 2ab cosine c, right? But then I like to just keep it as c. So c is equal to the square root of it all, right? And then if I wanted b, right, it would equal the square root of a squared plus c squared, right? Minus 2ac cosine of b. Okay? And then of course, if I want a, is equal to the square root of b squared plus c squared minus 2bc cosine a. Okay? So those are the ones. And you know what's great about this? None of these will work for this problem. Isn't that not awesome? Right? So what this works for is if I don't have one of these sides. So should we use this first and then we'll talk about the next one? Okay? So we'll do this one first. This is Law of CoSines. And we're going to continue using that problem that we did before, right? With similar numbers, right? So let's say I come up with 85 degrees here, right? Because that's similar to the one we did before, right? It was 85.6, but let's just call it 85. So we know it's going to work this time, right? We know it's going to work. But the problem is, I don't have the side across from it. Okay? Now, I also don't have these angles, but I don't need them, do I? With the law of cosines, I only need one angle, but I need two sides. I have two sides and one angle. Okay? So that's what this is kind of set up for. Alright? So when you don't have the side across from the angle you do have. If you have the angle that's across from the side you do have, use law of sines. It's a lot easier, right? This is a much harder formula. Correct? Alright. So let's just, which one do you want to use? A, B, or C? Because that's really, you want to use B? Alright, let's use B. So we're going to look for B. So we're going to have B here, right? So if we have B here, what's this angle?
84.
Yeah, it's 85. But what is the angle called? Angle B.
Oh.
Right? Now, it don't matter which one of these is A and C, right? Really doesn't matter. This could be A, and this is little a, right? If this is C, then this is little c. That's all. Okay, because the angle and the sides are correlated, right? Corresponding. So you want to make sure that your big A is across from the little a, and your big B is across from the little b, and your big C is across from the little c. And then, all we need is that. Say no more. Right? And then you plug it in. Do we have B? No, so it's just B. Square root of, what's A? 10 squared plus 14 squared minus 2 times 10 times 14 cosine 85. And then you just plug that in your calculator and you work it out. And that's it for today? Seriously. Where's my calculator? And drop it right there in the book. It's in the book. In the book? So let's just calculate this out real quick. How would I calculate this? Right? So what I typically would do is I type this all in the calculator myself. I would say 10 squared, let's turn it on, 10, there's a square button here, squared, plus 14 squared, right? And then minus, and I'd have to use the quantity button, meaning the parentheses, right? Because I want to do all of this. I gotta minus all of this, right? So I want it to do all of that and then minus it, right? So I would do 2 times 10 times 14 times cosine 85, right? And then in the parentheses, and hit equals. Okay, so we get the square root of 271, 5, right? And then I hit square root, so it's second squared, and then second answer, and hit equals, and I get B is equal to 16.5. Now, is that close to what we said it would be? It says 16.6 here. We found 16.5. That's really close, right? So we know we're on the right track. So that's how you do that, and we'll work on the rest of it tomorrow.